Welcome to the Right Science Daily Revision Boost. First thing, a big well done to our top 3 scorers from our day 1 quiz, which are Izzy, Fatima and Kevin. So well done. Let's see if you can make it to our top 3 next time. Today's daily formula for you is acceleration. So acceleration is measured in meters per second squared and is the change in speed in meters per second divided by the time in seconds. In our biology blast today, we're going to look at respiration. So first thing we need to know is that not everyone needs the same amount of energy, and the amount of energy that you need will depend on a range of factors like your age, your lifestyle, your gender. We can actually measure this by using what's called the metabolic rate, which is the speed at which your body uses the energy. So the higher your metabolic rate, the more food you need to eat. 3 of the most important components of your diet: carbohydrates, proteins and lipids. Carbohydrates are polymers made from simple sugars and we use them for energy, and when we break them down into their monomers, which are those simple sugars, that's carried out by carbohydrase enzymes. Proteins are again polymers made from amino acids, and the sequence of amino acids tells us what protein we've got. We use proteins for growth and repair, and they are broken down by protease enzymes. Third group, the lipids, are used for energy, buoyancy and insulation. They're made from 3 fatty acids and a glycerol molecule, and they're broken down by lipase enzymes. And what we find is that when we break those down, the pH decreases because we're releasing the fatty acids. When we're talking about respiration, this is a process that happens all the time to provide energy for all of the life processes. It takes place inside the mitochondria in our cells because they contain the enzymes we need. Depending on what kind of cell we're talking about will determine the number of mitochondria present. Things like muscle and liver cells have lots of them. First type of respiration, aerobic respiration, is a whole series of chemical reactions that we can simplify down to glucose plus oxygen makes carbon dioxide and water. Make sure you know the chemical formulas there. It's an exothermic reaction, and what we find is aerobic respiration produces more ATP than anaerobic. If there is a lack of oxygen, then our body uses anaerobic respiration, which is glucose being converted into lactic acid. So, quick comparison, aerobic respiration produces more ATP per glucose molecule than anaerobic, and it doesn't produce lactic acid, which leads to the muscle fatigue. One thing we should remember though is that anaerobic will be used to transfer energy quickly and provide energy when oxygen is not available. If we've used anaerobic respiration, we build up what's called an oxygen debt. So what we find is our heart rate and breathing rate stays high after exercise because the oxygen is needed to break down the lactic acid. Another example of where we find anaerobic respiration is in fermentation to produce ethanol. So this is yeast that carry this one out. So glucose will form ethanol and carbon dioxide. Again, make sure you know the formulas. Quick reminder for you, today's daily formula, acceleration in meters per second squared, is the change in speed in meters per second divided by the time in seconds. For today's chemistry check, we're looking at C4. So first one, group 1. These are known as the alkali metals, the far left-hand side of the periodic table. A few key trends we need to remember is that as we go down the group, their density increases, their melting point decreases, they get softer and more reactive. We should remember they've got 1 electron in their outer shell because they're in group 1, and so they make ions with a single positive charge. The reason they get more reactive is that as you go further down the group, then that outer shell electron is further from the nucleus, so we lose it more readily. When we react them with water, we make our metal hydroxide, which is an alkali solution, and we make hydrogen gas, which we test for. A lit splint makes a squeaky pop. Group 7 are the halogens. They've got 7 electrons in their outer shell and make ions with a single negative charge. They go around as what's called a diatomic molecule, so there's two of them joined together. And a few trends as we go down the group, they change from gas to solid, they get darker in colour, their density, melting point and boiling point all increase, and they get less reactive. Because as we go further down the group, the outer shell electrons are further from the nucleus, so it's harder for them to gain that last one. If we mix two halogens together, we see something called a halogen displacement reaction, which is where a more reactive halogen displaces a less reactive halogen from a compound. So you can work out where that's happened by the colour change, and when we're looking at the equation in the middle there, you can see that chlorine is more reactive, so it's taken the place of the bromine. Group 0 are the noble gases on the far right of the periodic table. Key points about them, they're unreactive because they have a full outer shell. They are all gases, hence the name noble gases. They're monatomic, single atoms, and they're all non-metals. Trends as we go down the group for our noble gases, the attractive forces between the atoms get stronger, their boiling point will increase, and their density increases. If you're doing combined science, you don't need to know this. For those of you doing GCSE chemistry, you do. Transition metals, these are the ones that we find between groups 2 and 3 on the periodic table. They've got those typical metal properties of being shiny, good conductors of electricity, they're strong, they're malleable, so we can change their shape. We typically have them used as catalysts in a range of reactions, and they've got a few chemical properties we need to know. They react slowly, if at all. They produce coloured ionic compounds, and they can form ions with different charges. So Fe2 plus and Fe3 plus are both ions of iron. Hopefully you haven't forgotten that today's daily formula is acceleration in meters per second squared is the change in speed in meters per second divided by the time in seconds. Today's physics prep is going over the first part of P2. First thing we need to remember is how we carry out basic measurements. To measure time, we use a stopwatch. To measure distance, we use a ruler. We need to know the difference between a scalar and a vector quantity. So scalars have magnitude but no direction, things like time. Vectors have a magnitude and direction, things like velocity. When we're talking about vectors, we need to give them a positive or a negative sign so that they've got that direction associated. And that's really important when we come to add those vectors together. When we refer to acceleration, this can either be a change in speed, a change in direction, or both a change in speed and direction. And when we use the phrase negative acceleration, that's the proper way of referring to slowing down. And don't forget that when we're dropping something, the acceleration due to gravity is 9.81 meters per second squared. When we consider a distance time graph, we need to know what those lines on the graph actually represent. So the horizontal line is where it's stationary or it's not moving. The diagonal line is a steady speed. And then if we want to calculate the speed, we just work out the gradient of the line using our triangle method. Make sure you don't mix up distance time graphs and velocity time graphs. Remember, look at the y-axis label to identify which is which. So on a velocity time graph, the horizontal line means the object is going at a steady speed. If we have a diagonal line facing in a positive direction, that means it's speeding up at a constant rate. If it's going in a negative direction, it's slowing down at a constant rate. And if you want to know the distance the object has travelled, it's the area underneath the graph. Remember, divide it up into shapes you can work the areas out for easily. Final reminder of our daily formula then, acceleration in meters per second squared is the change in speed in meters per second divided by the time in seconds. Now we've had a quick recap, then head on over to socrative.com and test your knowledge on the topics from today. The room name you need to enter is Right 2662. Good luck! As always, if you want to know more or have more detail about any of the topics we've run through today, biology was the B1 playlist, for chemistry it's the C4 playlist, and physics is the P2 playlist. Hopefully we'll see you back tomorrow for our next daily booster.